Okay, this is another shot at the C1 video. I got a mic, so let me know if it's better. Okay, so in C1 we've got 4 tasks. We got to figure out a vector, what a vector quantity is versus a scalar quantity. We have to represent vectors Okay, did anyone realize I spelled geobraically? Geometrically and algebraically. And we have to convert between algebraic and geometric vectors, and then we're going to talk a little bit about 2 and 3 space and algebraic vectors and the distance between them and their magnitudes. Okay, so just quickly, vector versus a scalar. So vector, we've got direction and magnitude, whereas a scalar quantity just gives us a magnitude without direction. On a test, you could get asked to give an example of them, to explain what a vector is. I could give you examples, and you could have to pick which one's vector, which one's scalar, and say why. Okay, the second thing is representing geometrically and algebraically. So geometrically, we represent vectors as a directed line segment. So it could be a line segment that's like that, and maybe the line segment is like north, 30 degrees east, and it's 100 kilometers. So that's how we could represent it geometrically, as a directed line segment with a direction and a magnitude. And then algebraically, okay, so we could also write this geometric vector, as 100 kilometers north, 30 degrees east. So you should be able to draw it, write it, and then algebraically we could represent a vector as a coordinate. So we could have the vector 1, 3, and it's in square brackets, and we know that vector would look like over 1 on the x-axis, up 3 on the y-axis. So that vector would look like that. So our algebraic vectors are split into its x and y components. And then in this section too, you should also be able to explain what opposite vectors are, equal vectors, parallel vectors. So opposite vectors are just completely going in the opposite direction. So you should be able to figure out what their angle would be. So this would be 30 degrees. So instead of north 30 degrees east, it would still be the same magnitude, 100, but now it would be south 30 degrees west. So it would be an opposite vector. Equal vectors would be the exact same magnitude and direction, and then parallel vectors would be not necessarily the same magnitude, but the same direction. So I could have one vector of this length and another vector of this length, and they're parallel, they're both going east, but one's larger than the other. So you should be able to know the difference between those 3. Okay, next task is converting between an algebraic and a geometric vector, so being able to go both ways. So if we had a geometric vector like the one we just had, so let's say we had one that's north 30 degrees east, and it's 100 kilometers. So there's our geometric vector. So that's our geometric vector, a directed line segment. And let's say we want to represent that as an algebraic vector. So we want to represent it as an algebraic vector. So we know it's going to be a coordinate there. So we need to find the components of that vector. So we need to figure out what's the x component and the y component. So that's going to give us a 90-degree triangle. We know this angle by the positive x-axis is 60 degrees. So all we're doing is we're trying to figure out the vector's x component and the vector's y component. So you could just write that vector as, so I know the x component is going to be 100 cos 60, and I know the vector's y component is going to be 100 sine 60. So I could just write it like that, or I could write it with the actual numbers. I don't have a calculator, so whatever that would equal. Either one is fine. This guy right here is like the exact answer. So it's not, you haven't rounded anything. Whereas this one here, you'll have a decimal answer, so you'll have rounded it. So just be aware of what I'm asking. If I say exact, then don't calculate it. If I don't specify, do whatever you want. Okay, and then if we wanted to go backwards, if we wanted to start with an algebraic vector and turn it into a geometric guy, let's say we start with a vector 5, -2. And we want to represent that as a geometric vector. So let's sketch it out. So we've got 5, -2. So I know my x component is 5 and my y component is -2. So I'm trying to figure out the magnitude of my vector first. So I'm going to figure out the magnitude of s. So to find the magnitude of a vector in 2 space, we just do x squared plus y squared. And I would get root 29, which you can leave it as root 29, or you can figure out what that equals, but I don't have a calculator, so I'm leaving it. So now I know the magnitude of s, vector s, so root 29, and I'm going to need an angle. So if I want to find that angle in there, I can just use inverse of tan, -2/5. I'm definitely going to need a calculator for this, so just one sec. Okay. No, sorry. Not prepared. Okay. Calculator. So we got -2 divided by 5. Second tan gives me -21.8, which I'm going to round to 22. It's negative because it's going in this direction, so I'm just going to ignore that and call it 22 degrees. So that's the size of that angle in there. So this angle here is 22 degrees. So if we wanted to say this as a geometric vector, we could say root 29, and then we could give it a direction. So I know this angle here is 90, this one's 22. So I could make it a bearing, and I could say that it's root 29, a bearing of 112 degrees, or I could say root 29, I could say east 22 degrees south, or if I wanted to be more official, I could say south 68 degrees east. So there's a whole bunch of different ways. As long as you're clear and it makes sense, I'm good with that. So that's how you convert between the two of them. And finally, you have to understand 2 and 3 space. So remember we talked about like 2 space, we just had like an x and a y axis, and then all of a sudden we're adding in another dimension. Like we've got our x, y, and z axis now. So I guess knowing how to find magnitude of a vector in 2 space and in 3 space. So for magnitude of a vector, we just use Pythagorean theorem, x squared plus y squared, and then in 3 space, we're just adding in a z component. So that's magnitude of vectors in 2 and 3 space, which you should be able to do. Distance between 2 points. So we talked about this in class. So finding the distance between 2 points for algebraic vectors means you're finding their magnitude, which I just talked about up there. So let's try one. So distance between 2 points. So if we have 2 points, 1, 3, and 7, 2. So let's sketch that. Sorry. Alright, so we got 2 points, over 1, up 3. So we've got this point, and then we got b over 7, up 2. 2. So if we're trying to find the distance between these two vectors, that means we're trying to find vector AB. So we're going to figure out what the coordinates of vector AB are. So here's A and here's B. So we're trying to figure out this vector here. So if you think about it, if we split this vector into x and y components, and you think, well, A, if we just think about x right now, A is at 1, and B is all the way at 7. So pretty much we're looking at the distance between A and B, which is 6. So another way to write that would be like 7 minus 1. And then if you look at the y components, we know A is up at 3, and we know B is just at 2. So the distance here for the y components is actually just 1. It's actually down 1. So it's like negative 1. So we do that by doing 2 minus 3. So to find the distance between your points, you're just taking the B point coordinate and subtracting the A coordinate. So like 7 minus 1 and 2 minus 3. So we get 6 and negative 1. Which makes sense, because to go from A to B, we go down 1 and we go over 6. Down 1 over 6. So that's AB. That's our vector AB. And if we wanted to find the distance between those 2 points, we need the magnitude of AB. So if we wanted to find the magnitude of vector AB, we're just doing 6 squared plus negative 1 squared, which is root 39. 37. No, yeah. I can't add. 6 squared is 36 plus 1. Okay, so root 37, sorry. And that's it. And I just had on the other video, like, explaining the differences between adding vectors and the distance between points. So this is when we had 2 points, A and B, and we're finding the vector between those 2 points. We call that vector AB. It's different than if we were to add these two. So if we were to actually take A and make it a vector, so we'll call that vector 1, 3, and then we had vector B, which is 7, 2. So this concept is different than adding or subtracting vectors. Like if we were adding 1, 3, so we're going over 1, up 3, and then we're going over 7, up 2. So then we're taking vector A, vector B, putting them tip to tail, head to tail, and then we're drawing our new resultant vector, which is vector A plus vector B. So that's going to be something totally different. It's going in a completely different direction than vector AB, so that's when we add our vectors together. And remember, to add the vectors, you can just add their components. So vector A plus vector B would be 8, 5, because you're just adding the components together. So vector AB has a x component of 8 and a y component of 5, so we could figure out the magnitude of vector AB by just doing the Pythagorean theorem if we wanted to. And then one more thing, if you wanted to subtract them, just to show you what that would look like, vector A minus vector B is the same thing as saying vector A plus vector, the opposite vector of B. So the opposite vector of B, instead of going in this direction, the opposite vector goes like that. But essentially, we're just, you know how we just added the x coordinates here? Well, to subtract a vector, to subtract 2 vectors, we're just subtracting them. So we just do like 1 minus 7 is negative 6, and 3 minus 2 is 1. So we're just subtracting their x coordinates and then subtracting their y coordinates, so we get a negative 6 and 1. So if you want a visual that if we take vector A, it's over 1 up 3, so there's our normal vector A, and then we take the opposite of B, which would be like negative 7, negative 2. So I'm going over 7 this way and down 2. So my resultant vector would look like this. Vector A minus vector B would look like that. Which makes sense. It'd be like over 6 to the left, so negative 6 up 1. Alright, hope that helps and hope my mic worked.